Okay, so what we've been trying to do with the Lake Associate, in collaboration with all our partners and friends, are trying to look at the sources and the magnitude of inputs of nutrients to the lake, and that will inform management activities. So what we try to do is we try to look at external inputs and internal inputs of nutrients. And there are two major nutrients of concern. The one that's probably paramount is phosphorus, because that's the growth limiting nutrient. The other one that's being demonstrated to be increasingly important is nitrogen. Now, nitrogen is not a growth limiting nutrient, but when these cyanobacteria produce their toxins, those toxins are highly enriched in nitrogen. So the presence of nitrogen is thought to drive the production of toxins and causing the problems in terms of the toxicity of the cyanobacteria. So there are different pathways in which they can enter the system. They can come in from the atmosphere. Most people don't think about that, but remember I told you earlier, and if I didn't tell you there's going to be a quiz at the end of the lecture, the lake surface is 23% of the watershed area, so the atmosphere is critically important to this lake. So it not only comes in for phosphorus, but also nitrogen. And there are two major forms of nitrogen. One called nitrate, which is largely from a byproduct of fossil fuel combustion, like cars and power plants and things like that. The other is ammonium, and ammonium is largely associated with agricultural activities. We'll talk about that in a second, and also a byproduct of catalytic converters from automobiles. The material coming into the atmosphere can also hit the watershed and run off. It can be leached from land, from agricultural activities, fertilizer production. It can also be produced internally within the lake. It can be released from rooted plants like macrophytes. When they decompose, it can be released to the lake. And then it can be released from sediments or retained from sediments. So anyway, these are all the pathways, and this is what we've been studying over the last few years to try to get a picture of what's going on in the lake.